This is Module 6, Lights, and up to this point I haven't used many lights in the example scenes because I wanted to keep the already complex program as simple as possible without adding more variables into the mix. But with a good foundation of the various GI solutions, animation procedures, and the various environment lighting techniques, we can now move on to coverage of the various lights that can be used within V-Ray. Besides all of the great V-Ray light types that we'll look at here in Module 6, all of the standard and photometric light types can be used as well, and as we'll see, there are situations when each type of light comes in handy and provides its own unique qualities. This is not a class on how to create or work with standard or photometric lights. I'm making the assumption that you already understand the important controls of these lights. I'm going to start by analyzing the V-Ray light, what it does and how it can be controlled. The V-Ray light has three different subtypes, and the only difference between the three types available, which are the plane, the dome, and the sphere, is how the light is emitted. In the last module on HDRIs, we already got a feel for how the V-Ray dome light is utilized, although many of the controls were left out of the discussion. While discussing the V-Ray light in this module, I'll bring some standard and photometric light types into the scenes to see how they can be used instead of V-Ray lights or in conjunction with them. So let's get started with an explanation of V-Ray lights. Well, the V-Ray lights are found in the same place as the standard and photometric lights, and when you select the V-Ray light menu, you see two different options, V-Ray light and V-Ray sun. We'll look at the V-Ray sun in just a moment, but for now let's concentrate on the various V-Ray light types. Since all three V-Ray light types are identical with the exception of the area from which the light is emitted, I'm going to focus on the V-Ray plane light, and afterwards I'll briefly talk about the others. When you select the V-Ray light type, the default plane option is shown. The plane light type casts light from a specified area, specified precisely by the half length and half width parameters. This type of light is an area light, similar in function to the photometric area light, because the light does not emanate from one distinct point as it does with an omnilight, unless of course you specify a very tiny length and width. The plane option is really a fantastic light type used in many different situations, but it's really best suited and probably most often used for interiors, and in one very specific way. You could certainly use this plane light for exterior lighting, but this would be about my least favorite form of exterior lighting and my least favorite way of using the plane light. Primarily because it doesn't have the precision controls that a standard light has, to include attenuation controls, hotspot and fall-off controls, just to name a few. By default, the V-Ray plane attenuates and therefore illuminates nearby objects more than objects that are farther away. This is certainly not a desirable effect for exterior lighting, with the exception, of course, of lighting of nighttime scenes. However, you can prevent this type of light from attenuating by enabling the no decay option. So how is the V-Ray plane best utilized? Well, the answer is as a fill light supplementing other sources of illumination. Anytime you create an interior scene, you have to have light appearing to either come in from the outside through an opening, such as a window, or you have to have light that appears to be created inside. And of course you can have a combination of both, but regardless of which situation applies, the V-Ray plane light can help. So let's look at a few examples. If you want to follow along in this first scene, open the file called light01.max. In this first example, I have a room with one window opening. There's absolutely no illumination in the scene right now, and if I render with the camera that I currently have positioned, you can see this. The only thing not black is the background visible through the window. So I'm going to add a direct light to the scene, which is going to simulate the sun, and I'm going to have to make sure that the light shines directly through the window opening. For the sake of simplicity, there's no glass in this window. The first thing I need to do is make sure that the entire window opening is covered by the extents of the light, and I'll adjust the light's hotspot parameter to make sure that this happens. Be careful, by the way, to avoid using the scale transform to adjust lights. Whenever you use the scale transform on any object with parameters, you really invalidate those parameters because they don't change as you apply the transform, and this can cause a multitude of problems. So again, all I want to do is position the direct light so that it's shining through the window, and as a check, I can switch one of my views to the lights view and see actually what the light sees. I can see through the eyes of the light. And this tells me that the light is in fact coming through the window. Now, once light enters this window, it bounces off the floor and continues on by bouncing around all the different surfaces in the room. For interior scenes, you really need larger intensity values than the default 1.0 value. Here I'm going to use a multiplier of 3 and see how that works. I also need to enable V-Ray shadows, which I'll talk about in just a minute. When I render an interior view with this light, as you can see, the entire rendering is full of splotchy lighting. No matter how much I adjust the qualities of the GI, no matter how much I try to increase the illumination coming into the room by adjusting the intensity of the outside light or by adjusting things like skylight or color mapping, I just can't get decent results without using fill lights on the inside. I'm using an irradiance map with a low preset and 20 subdivisions and a light cache with 250 subdivisions, which is pretty typical of test renders. It's what I use often for test renders. This is by no means production quality. But just to show you how little increasing the GI quality is going to help in the scene, here's the same scene with a high preset, 50 subdivisions, and a light cache with 1,500 subdivisions. The best I could do would be to minimize my noise threshold to a value of 0.0 in the QMC sampler rollout. And if I did that, I could probably get a little bit better results than what I'm getting right here. There is still some splotchiness. Even if I could manage to remove all the splotches, which is unlikely, I would have to endure an excessive render time, which simply isn't necessary. Well, the first thing I want to do here is change the diffuse color of the dark tan walls. Just like in the real world, white surfaces reflect light and black surfaces absorb light. So the closer a color, or the diffuse color, is to white, the more illumination it will reflect. So instead of using such a dark color on the walls and increasing its apparent brightness by adding so much light, I'll first try to increase the brightness of the wall color and see if I can harness more of this light that I already have. So I'll brighten up the wall color a bit and render again with the same low test render settings I used before with just this one change. And when I do, this is what I get. A much brightened interior. Now I can continue from here. So I'll clone this rendering so that I can compare it to what I'm going to do next. And what I want to do next for demonstration purposes is to show you what happens when I take the roof off this room and render with the same light source. So I'll select the roof and hide it and render again. And when I do, you'll notice two things. First of all, it renders much faster, at least percentage-wise. A couple seconds really isn't a lot faster, but it is percentage-wise. And second, the objects rendered darker. The reason the scene rendered faster, and also the reason that the scene rendered darker, is because the only light source in the scene, the sun, entered through the window, bounced off the floor, and a good majority of it escaped into 3D infinity, never to return to further illuminate any of the other surfaces. So with the roof missing, only a small amount of light stayed in the room. With the roof on, the light is trapped, except for a small amount that can escape through the window opening. And because it's trapped, its energy is completely expended before it can escape. And the end result is a much brighter room, however still far from desirable GI. Now, if I make the simple change of adding some skylight to the scene by changing the environment light color from black to light blue, when I render this scene with just this one change, you can see that most of the splotches are removed. This is because with the roof off, more skylight can enter the room rather than just a small amount of skylight entering just through the little window opening. The skylight acts as a fill light, smoothing out the overall lighting by essentially adding illumination from all directions. And with more skylight added to the scene, I simply get better results. This is just another form of a fill light. I'm going to leave the skylight for the remainder of this demonstration because it's really a necessary element. It's found in the real world, and it should be in most 3D scenes as well, at least for daytime scenes. So how do I create a nice fill light for the scene without having to take off the ceiling? The answer is the V-Ray plane light. By placing a V-Ray plane light just inside the window opening, you can accurately and realistically add to the overall illumination inside the room and keep the viewer believing that the only source of illumination for the scene is the sun outside. If you put a V-Ray plane light just about anywhere else other than this window, it might be obvious that the sun is not the only source of illumination. You don't have to be so precise with the placement of this light inside the window to the point that it fits perfectly within the window opening, but you do want to make sure that the light doesn't intersect any objects, such as the wall itself or the window frame. If it does, you're likely to get some erratic GI in some areas. So I'll render the scene again with the V-Ray light in place using the default light settings. And as you can see, when this renders, I've got a couple problems already with this image. First, it's far too bright, so the first thing I need to do is reduce the intensity from 30 down to something more manageable, something more reasonable like 10. The next thing I notice wrong with this rendering is that the light is actually visible as a white plane, which is not only bad, it not only looks bad, but it also blocks some of the illumination coming through the window. So all I need to do is enable the invisible option, and when I render again, I should have a much better looking image. But clearly there's still room for improvement. The bright burned out area on the ceiling is not realistic at all, so the next thing I want to do is tone down this area. And the best way to do that is to change the color mapping from linear to something else. So I'll go to the color mapping rollout and I'll try exponential, which helps reduce extreme values in illumination like the one I have on the ceiling. So when I switch to exponential and render again, this is what I get. Much better results, much more aesthetic appearance to this image. But I want to make a few more adjustments. First, I don't want the exponential color mapping I'm using to affect the background color, so I'll disable the Affect Background option in the color mapping rollout. Lastly, I want to increase the GI quality, so for the radiance map I'll use a medium quality preset, and for light cache I'll use 500 subdivisions. And in the QMC sampler, I'll cut the noise threshold in half and bring it down to a value of 0.005. When I render with these settings, as you'll see, I get all the quality I need throughout the entire image. Now there's not a whole lot of detail to bring out, but still I get a nice good spread out GI. Everything that I see in this image is perfectly normal, perfectly realistic, and this is a decent rendering at this point. If there were any problems at this point, I would adjust settings one at a time to figure out where to get the most bang for the buck. But at this point, the image looks fine, despite the fact that the settings I've used are really relatively low. The last point I want to talk about before moving on to another light type is exactly where the V-Ray light plane should be positioned in a window, i.e. should it be inside or outside, should it be as close to the window frame as possible, that sort of thing. For demonstration purposes, I'm going to move this light that we already have in the scene just outside the window opening. It's currently inside, I'm just going to move it a little bit outside. When the light is moved outside like this, not only do I have less illumination making it into the room, the illumination is less accurate. So when I render this, you'll be able to see just what I'm talking about. The illumination in the room is much less, and notice some splotches returning that we didn't have before. So keep the light inside the room whenever you can. Sometimes this isn't always possible, and we're going to look at just what I mean by this. Okay, enough with the scene. Let's look at an image from another scene and see how it was created. This scene uses the same basic setup just described, a direct light acting as the sun, and a V-Ray light, a plain light, just inside the window acting as a fill light. Notice the light was placed outside the window frame, just outside the window frame rather than just inside. And this was done only because the tight space we had to work with and the inability to fit the light in between the window and everything else around it, i.e. the blinds and the plant. Lights outside like this usually mean that you'll have to use slightly higher quality settings, but you really need to do this to avoid the splotchy lighting that just really comes about when you put the light outside the window. It's a minor inconvenience most of the time, and it just means you'll have a little bit longer rendering time. The important thing to understand is that the viewer needs to understand that the only source of light for the scene is the outside light. You just can't let them know that you have a light sitting in the window by having any erratic lighting around the window opening. Also remember that you could and probably should have a V-Ray plain light in every wall opening in your scene, whether a window, a door, or anything else. Unless, of course, you have so many openings that it's just not time-wise practical to do so. Well, that does it for the plain option, the plain light. Now, as I mentioned, the only difference between the three V-Ray light types is the area in which the light is emitted. The dome light, the second option you have available, the dome light acts as a skylight by emitting light from a virtual dome surrounding the scene and illuminating the scene from all directions. It's a great type of skylight to use regardless of whether you're going to use an HDRI with it or not. Since this type of light was discussed at length in the last module, I'm not going to spend a lot of time on it here. Instead, I'll just highlight one important thing. There's a spherical dome option at the bottom of the parameters rollout, which should really only be used when an HDRI is used. When you have a good spherical HDRI, you should use this option because the bottom portion of an HDRI should represent the area of the image below the horizon and thus have a different amount of light emission in that area of the HDRI. If you use the spherical dome option without an HDRI, you'll just have as much skylight emanating from below the horizon in your scene as you will above the horizon in your scene. This would obviously not be so realistic in a 3D scene, so just avoid this option unless you're using an HDRI. All other light controls in the three rollouts, the three V-Ray light types are identical to the V-Ray plane, so I'll leave the discussion at that. Now let's briefly look at the V-Ray sphere light. This light is similar in function to the standard OmniLight or photometric point light in that it emits light in all directions from one distinct point in space. Like the other V-Ray light types, the sphere type can be made to not decay or attenuate, but I don't recommend using this option in most situations since doing so wouldn't simulate the attenuation effect lights go through in the real world. If you think about it, V-Ray sphere lights will almost always be used to simulate artificial lights such as light bulbs rather than sunlight. Exceptions can always be made, like using the sphere to simulate light coming from a fireplace, but the important thing to remember is that the V-Ray sphere light is usually confined to use for interior scenes or nighttime exterior scenes. For these situations, this really is a good option to use. It really is a good light type to use, and here are a few examples. Here's an image where the only other source of illumination besides the sunlight was a V-Ray sphere light sitting inside the chandelier above the dining table. We could have used the V-Ray plain light inside the window frame, but it really wasn't necessary because the sphere provided all the light, all the fill light that was needed. Actually, underneath the cabinets in the kitchen, there's a small amount of illumination coming from, I think, a V-Ray material light, which is a light source that I'll be discussing in a minute. But in this scene, this really is a negligible amount of the overall illumination. Here's a nighttime scene where a V-Ray sphere light was used to provide a small amount of attenuated light like you would find with a light bulb. In this scene, several of the lights were used in the street lamps in conjunction with the V-Ray light material that I just mentioned. Really, there's so many ways that you can use lights. You're often only limited by your imagination. Well, that does it for the V-Ray light type. Hopefully that wasn't so bad. Now it's time to switch gears and take a look at another great V-Ray feature, the V-Ray Sun. This is a new feature to V-Ray version 1.5, and when it came out, it quickly became a favorite among V-Ray users. It simulates the look of real sunlight while providing several real-world characteristics such as air purity and skylight. I use this light type occasionally, though rely most heavily on a simple direct light to simulate the sun, as I've already mentioned. The characteristic I like most about this particular type of light is the built-in skylight that it provides. So when you create a V-Ray Sun, you're asked if you want a V-Ray sky map placed in the environment map channel automatically. And if you agree, the qualities of the V-Ray sky are linked directly to the location of the V-Ray Sun. So in other words, if you place the V-Ray Sun low on the horizon, the resulting skylight will provide a nice and realistic sunset. But if you move the sun higher in the sky, you'll have a brighter scene more indicative of a midday sun. So creating this type of skylight manually can be difficult and time-consuming. So let's see all of this. If you want to follow along in the same scene that we're going to be working in, open the file called light02.max. So in this scene, the only source of illumination I have is the environment light color swatch. And to see what I have to start with before adding the V-Ray Sun, I'll render the scene as is, and when I do, this is what I get. Not much to look at, obviously. But now I'll add a V-Ray Sun and answer yes to the question about whether or not I want the V-Ray sky map to be placed in the environment channel automatically. Now, having answered yes, if I open the environment and effects dialog box, I see the V-Ray sky map loaded. And I can control this map more precisely if I instance it into the material editor. Once in the material editor, I see just a bright white map, and this is because the V-Ray sky map is linked directly to the V-Ray Sun, which has too large an intensity value right now. Well, fortunately, the V-Ray Sun feature is as simple as it is effective. There aren't many parameters that control its behavior, and most of them aren't even necessary. By far the most important setting in the V-Ray Sun feature is the intensity multiplier. For exterior scenes, the default intensity multiplier of 1.0 is really far too great, although it may be suitable for some interior scenes where really only a little bit of sunlight is allowed to get through. But for exterior scenes, start with a value of 0.01 and adjust from there. So if I use a value of 0.01, I see the V-Ray sky map in the material editor adjust in intensity because it feeds off the values stored here with the V-Ray Sun. If you don't want the V-Ray sky map to feed off the V-Ray Sun, simply enable the manual sun mode. Although if you're using the V-Ray Sun, I don't know why you wouldn't use the two features linked. The primary reason you should keep the V-Ray sky linked to the V-Ray Sun is the V-Ray sky map not only feeds off the values of the V-Ray Sun, it also feeds off its position in the sky, and I'll explain what I mean by this. Since the V-Ray Sun casts parallel rays just like a direct light, and since the intensity doesn't change over distance, i.e. since there's no attenuation, the X and Y position of the sun is really irrelevant. It can be anywhere in your scene. Of course, the X and Y position will determine where the shadows fall, but my point is you don't have to worry about placing the sun close to your scene or far away from it. What really matters is its Z position, i.e. how much up in the sky is it. Notice that when I have the V-Ray sky map from the Environment Effects dialog box instanced into the material editor, the look of the V-Ray sky map changes. The background changes as I change the height of the V-Ray Sun. When the light is low on the horizon, I get a background indicative of a sunset, and when the light is directly overhead, I get a background indicative of a midday sun. Now, as I said, I don't know why you wouldn't keep the V-Ray sky linked to the V-Ray Sun if, in fact, you use the V-Ray Sun. However, you can just as easily use the V-Ray sky without using the V-Ray Sun. For example, you can use a standard direct light, which, as a matter of personal preference, I use far greater than the V-Ray Sun feature. So if you do use another type of light like this, you can enable the manual sun node option, click the sun node button, and in one of the viewports, click on the light that you want to tie the V-Ray sky map to. Now, when you move this light, the V-Ray sky map in the material editor in the sample swatch, sample slot, adjusts to the light's elevation, and when you render this scene, you would see that it is in fact adjusting to the light's elevation. A really nice characteristic about the V-Ray sky map is the wonderful look you get in the area around your light. When I render with this light in view, I get a really nice realistic look and almost a hazing glow around the light, much like you would see in real life. However, when you move the light closer to the horizon and render again, you start to actually see an unrealistic look to your sun. And it's mainly because you can see its circular perimeter and it's just too sharp. If you want a really nice look around your light, I recommend using the glow lens effect in the environment effects dialog box. This feature gives you a really nice look to the sun, and you can see this when rendered. And best of all, you can control this type of effect with really great precision, unlike the effect of the glow around the light when using the V-Ray Sky Map. And you have a lot of control over this effect as well as other effects available in the same area inside the environment effects dialog box. But an important note about adding the glow lens effect to a V-Ray sun: when you add this effect to the V-Ray sun, you really need to be careful about where the V-Ray sun is located in X and Y space. And I know I just said the X and Y position doesn't matter, but this is one case in which it does, and let me show you why. Because this is a V-Ray sun, V-Ray doesn't consider the position of the sun to be where you see it in the viewport, but rather where it would be if this line right here, drawn between the sun and the target, were to continue out into infinity. So if you look at the V-Ray sun at an angle like this, you might be completely disillusioned about where you expect to see the sun in your scene, and you won't see the glow lens effect occur in the right place. When I render with the V-Ray sun too close to my scene and at such an angle like this, the glow lens effect is applied in the wrong place. It occurs where the V-Ray sun is shown in the viewport rather than where the V-Ray sun actually wants to project itself from, way out in infinity. So the simple solution to this is to move the V-Ray sun at least a good distance out and away from your scene. And when you do, you won't run into the problem of misinterpreting where the sun wants to actually exist. As a final note to this discussion on the V-Ray Sun and V-Ray Sky feature, let me just say the Chaos Group manual states that the V-Ray Sky yields its best results with the V-Ray camera. However, on a personal note, I haven't found anything but negligible differences between the qualities that can be achieved with either. I consider the V-Ray camera an advanced feature, which is why I've reserved a discussion on this particular feature for the next module, Module 7, Advanced Features. Although I will discuss briefly, I don't recommend using the V-Ray camera until you're completely comfortable with all the major lighting features in V-Ray. Otherwise, you're only going to add to the already long list of variables in an already complex program. Well, at this point in the module, I need to cover a critically important light quality that hasn't really been addressed much in any of these modules so far, and that would be shadows. There are several different shadow types to choose from with standard and photometric lights, but whenever you use V-Ray, you really should only use the V-Ray shadow type because it's optimized for use with V-Ray, so it renders much faster than any other shadow types, and also it produces more accurate results. Certain shadow types, like ray trace shadows, won't even work with V-Ray. Perhaps the most desirable characteristic 3D users try to achieve with their shadows is a nice soft look to the shadows. And this is certainly an area where V-Ray shines, no pun intended. When you enable V-Ray shadows, the V-Ray shadows rollout appears, showing an option for area shadows. And this is a fantastic feature that simply blurs the shadows cast by the individual light. And let's see how. So in this same exterior scene, I've replaced the sun with a standard direct light positioned in the exact same place the V-Ray sun was previously positioned. I'll render as is without area shadows, and what I get is fairly crisp shadows. Now I'll enable the area shadows option and render again. And when I do, you'll see not much has changed. And the reason why is I have to adjust the UVW sizes to make the shadow transition occur over a larger area, thus making the shadows blurred. When I change the UVW sizes from the default 10 inch to 10 feet, my shadows then become blurred. An important thing to remember with area shadows is that the UVW sizes become invalidated whenever you scale the light. And I talked about this before, but again, what I mean is if you scale your light 100%, not by using the hotspot and fall off values, but rather by the scale transform, you'll need to resize your UVW values 100% larger to get the same shadow effect that you would have not scaling the light. And this is a common problem with the scale transform. It usually invalidates all parameters. A more simplistic example would be in the creation of a sphere. I can create a sphere and set the radius to a particular value, but as soon as I apply a scale to it, as you can see, the radius parameter is no longer accurate. The radius doesn't actually change when I scale the sphere. I could resolve this discrepancy by going to the utilities rollout and using the reset transform feature, which essentially adds the XForm modifier, and if I then reset the XForm modifier, once I go back to the modifier panel and delete the XForm modifier, I see the sphere return to the radius specified by the radius parameter. And it's really just a good idea to avoid using the scale transform as I've used here, and doing so will avoid this kind of problem with lighting. Another important setting, and one that controls the quality of the shadows, is the subdivision setting found within each light. Increasing this value can significantly improve the look of all shadows cast by the individual light by reducing the noise within the shadows. In the case of the area shadows here, watch what happens when I use the lowest possible value of 1 and render the scene. I get noisy shadows, especially in areas where the shadow transition occurs over a larger distance. So you see this noise start to appear, and the more likely reason is the subdivision value. For test renders, the default value of 8 works pretty good, but for production renders, I recommend using a value of 15 to 20. You can try using the smooth surface shadows option to do exactly as its name implies, smooth the noise in the shadows. And this is a nice way of not having to use such a high subdivision value, but you usually can't get the soft shadows that many users go for with the area shadows option. Okay, well, the very last thing I want to talk about in this discussion on lighting is another light source unique to V-Ray, the V-Ray light material. This is neither a real light nor a skylight. It's simply a material that, when applied to an object, causes the object to illuminate from all faces. And this can be effective in many situations, and let's look at a few of them here. So to demonstrate how nice this feature is, I'll return to the scene again, only this time without any sunlight, without any fill light or skylight. I'll simply create a line, extrude the line a small amount, position it as needed, and apply the V-Ray light material to it. I'll try the default intensity value of 1.0, and when I render, I get a pretty neat look to the scene. Now this is a bit dark, and I'll try the emit on backside option, which simply makes both sides of the object emit light. Now when I render, I essentially get twice the illumination, but notice how splotchy the GI is. Like with most light sources this week, I get highly undesirable splotchiness, and I'm forced to use some better GI settings. This is just a downside of using low-powered, low-energy lights. The setting that is most likely to help out in this situation is the noise threshold value in the QMC sampler rollout. Unfortunately, to get really smooth GI with such a weak light source, I need to use a really low noise threshold, values approaching 0.0, possibly 0.01. What makes the light material so great is the fact that you can turn any object and any surface into a light source. And this really is a nice thing to have when you're trying to provide illumination over an irregularly shaped area such as light bulbs or neon signs. You can even make your object casting light be invisible to the camera while keeping the illumination. So I'll do that here. I'll go to the Object Properties dialog box and disable the feature that allows me to see the object with the camera, and when I render, the object will be gone, but the light will still be there for the illumination. Well, that's it for this module on lighting, and this may have seemed like quite a bit of material, but if you take a step back and watch this video again and see what was covered, you might agree with me when I say that there's really not much to it. And that may seem like a pretentious comment, but when compared to other things like GI solutions, image sampling, or even materials, When explained in a simplistic manner, which I hope I have, the various lighting tools that I've discussed just don't seem to be as complicated as many of the other areas in V-Ray. And as a review, let's do a recap. There's 6 primary sources of illumination in V-Ray: standard lights, photometric lights, V-Ray lights, skylight, the V-Ray sun, and the V-Ray light material. Hopefully you already have a decent level of understanding of standard and photometric lights, hopefully before you started this module. In Module 2, we looked closely at the skylight, and hopefully you had a pretty good grasp of that source of illumination. In the last module, Module 5, we looked at the dome light, whose controls are nearly identical to the other 2 V-Ray light types we looked at in this module, the plane and sphere options. Of course, this was the first real discussion on the V-Ray sun and V-Ray light material. Well, if you're a new V-Ray user, I recommend using a standard direct light as the sun in your scene and perhaps experiment with the V-Ray sun down the road. A couple things to keep in mind: make sure you adjust the scope of the light using the hotspot and fall-off values rather than scaling the light so that you don't have invalid light parameters. For the shadows, always use V-Ray shadows, and to get that nice soft look to shadows, enable the area shadows option. For important subdivision settings, use a value of 8 for test renders and a value of 20 for production renders. Try to avoid values above 30, which could lead to excessive render times. Remember that the weaker your light source, the more likely you will have uneven GI, i.e. splotchiness. And I equate this to rolling a bowling ball down a bowling alley. If you roll it with a lot of energy, you have a pretty good chance of at least sending it where it needs to go. But if you roll it with hardly any speed at all, it's likely to roll into one of the gutters before ever reaching the pins. And the same thing happens when you don't have much energy in your light. It just doesn't go where it needs to go. The dome option is a great option for skylight, regardless of whether or not you're using an HDRI. And I didn't really mention it, but you might want to use a little color with your lights, just barely enough, maybe a little bit off pure white, just to add a little more realism to your scene. For example, on an outdoor scene, you could give your sunlight a very small amount of yellow to simulate the yellow look of a midday sun. The same applies to interiors. Just a small amount of color can really do wonders. And you can even refer to the color swatches found in the various photometric color light types as a guide. Speaking of photometric lights, I didn't really talk much about them in this module. Again, this wasn't intended to be a class on photometric lights, but this particular type of light is perfectly legitimate for use with V-Ray. And perhaps the best benefit of these light types is their true physically accurate nature. They're supposed to be physically accurate, and I've never personally worked on a job where this has even been desired by a client, but everyone has different clients and everyone works in unique fields, so you might find a need for this. Like so many other areas of 3D, lighting in V-Ray with all these great tools means you're only limited by experimentation and imagination. And with that, I'll conclude Module 6.